Hello, everyone. My name is Willem Van Onsem, and I'm going to talk about advanced pod converters, or as you see a subtitle, it essentially explains it already a bit. We are going to talk about how to define pods based upon models. Now, pods are typically a bit the boring stuff in Django. I mean, you do a lot of interesting stuff in the views, in the models, in the serializers, etc. And what do the pods do? Well, the only thing they are really responsible for is routing the requests to the right view. So it basically works as a traffic sign that routes requests to the correct city or the correct lane, right? But well, I think I discovered, probably not as first one, but a few interesting topics about pod converters I'm going to discuss here. And so there are essentially two topics I will discuss: model-based pod converters and automated overlap checking. Now, we will see that the two topics are, of course, a bit distinct, but still have something in common. So the first topic will be model-based pod converters. And well, most of you, if you develop in Django, write pods and views all the time. And typically what you do is you define a pod where you, for example, have a certain pattern. And in that pattern, you use a primitive type, like, for example, the str for a string that will then take the username. And in the view, what you do is you make a database query, or you do something else with the username, but a typical use case is a get object or 404, where you request to the database a user with that username, right? Now, the question might be, how does that exactly work? I mean, what does Django do behind the curtains to make that actually work? Well, if you were a developer before 2017, you actually defined pods in a totally different way. At that time, it wasn't pod, it was URL. And with the URL, you defined the regex, and in the regex, you could define capture groups. And then you wrote a view, and so what happened was the pod was matched against all the regexes, and if one of the regexes eventually matched, what they did was the view is triggered, and the capture groups are passed to the view as parameters. And so that means that article ID, regardless what that was, and in this case it's a number-like thing, it will always be passed as a string. So in the view, you sometimes had to do a lot of processing to convert the string to an int, right? And so, well, everything went well until in 2017, Fridtjof Postmus introduced pod converters, so a new syntax for pods. And a fun fact is, I saw that change. I was sitting on the first row when that change happened. Why? Fridtjof Postmus was my manager back then. And so I didn't have anything to do with it, but well, he discussed a bit what he was trying to do over there. And so what he did was, if you look at the Django source code, you have the Django URLs converters module, and there you have a class like struConverter. And struConverter essentially has three items. It has a regex, it has a toPython function, and a toURL function. And so what does these three components do? Well, the regex is injected as a part of how the pod pattern should look like. So in case of a str, it's just a sequence of non-slash characters that can be arbitrarily long, but at least one character. And what does toPython do? Well, it parses the value that is captured by the regex. So in this case, it doesn't do much. It simply returns the value that it has captured, but you can use it for more advanced tooling. And the toURL does something in the opposite direction. That is used when you, for example, use a reverse, a redirect, or the URL template tag. In that case, it will first convert all the parameters it passes with the corresponding toURL and use that to build up a pod, okay? And at the end of the code, you see that we register that converter as str. Now, str is, of course, not very advanced, you would say. It's actually quite simple, but the nice thing is you can make custom pod converters. For example, I can here define a date converter with a regex that has 4 digits, a hyphen, 1 or 2 digits, a hyphen, and finally 1 or 2 digits. And the toPython function then parses the date string, and it uses, in this case, the parsing module of the datetime package for that. And the toURL does the opposite. It first checks, do we have a date object? In that case, we formatted this as year month date. And if it's not a data object, in this case, we will just assume that it is somehow already formatted correctly, so we will return the value. And why is it useful? Well, we can register the path converter as date, for example, and then we can use that as, between the angle brackets, you see before the colon, date star. And that means that from now on, it will take the regex defined in that path converter, and so it will also parse the date through the parsing of the datetime module before passing the object to the view. So that means that if you see at the bottom the view, my date is a date object. It's no longer a string, right? And I think, well, it's a bit an underestimated feature of Django because you can use it to actually shorten a lot of the logic. And actually, when I saw that, at a certain point in time, I had an idea. Maybe it's interesting to do something more special with this. What if we would work with models directly? So how would we do that? Imagine that we have a path converter that we here have named user path converter. And the regex is just an arbitrary string of word characters. And what we can do is in the toPython function, we just make a database query. We were asking, is there a user with that username as value, right? And if there is no such thing, then we raise a value error. And the toURL, which again does the opposite, it works in the opposite direction, first checks, do we have a user object? If that's the case, we return the username. And otherwise, we assume we already have the username as a string. Now we can, just like the date path converter, register our user path converter as user.username. That makes it clear what model we are talking about and what field we are using. And then we can define a path like profile user.username user. And so now what happens, if we now have a view that is linked from that path, we now can use the user parameter as a user object. So for example, if we print user.email, it will print the email of the user. So behind the curtains, Django will already have made the query and knows for sure such object exists before even triggering the view. And another nice thing is that you can use it in the reverse direction as well. So if you have a template where you have a URL template tag, as parameter, we can use the user object directly. So there is no more need for user.username. We can simply pass the user object, and the path converter knows, oh, I have to use the username of that user, right? So it makes the reverse shorter as well. Now, of course, we are not going to define a path converter for every model. That would be a lot of work. But, well, if you have the logic for one such model, you can easily generalize it to let it work for all registered models and all unique fields of all those registered models. And that's, of course, quite useful to then start defining paths. And a bonus of this is that actually you can let this work with different paths that have different models they are triggering. And why does that work? Because the path converter has something special. If it raises a value error, it does not stop at the path, it looks for other paths that are matching. So that means that we can here define a path anything that will first look for a user with that username. And if that fails, it will look for a group with that name. I would, however, not recommend this approach. Why? Because there can be an overlap in the ID space. Imagine that you have a user with username admin, and you have a group with name admin. Then which one do you want to pick? In this case, it will be the first one, but that just means that if you would later on in your application create a user with admin, all of a sudden there can be a different page that is showing up. And a second reason why that's probably not a good idea is because if you have a long sequence of all those paths who are overlapping, it can create a lot of queries before it finally finds the thing you're looking for. So it will first look, oh, do I have a user with that username? No. Do I have a group with that name? No, and so on. So it makes the logic quite generate a lot of queries. Now, the sad part of this approach is, of course, that we make queries eagerly. So imagine that you, for example, have a view that is login required. Then even if the user is not authenticated, it will first fetch the article and then fetch the user. Whereas if the user is not logged in, we have fetched the article for nothing because the view will simply reject to get triggered. And so we are doing useless database queries. But we can actually resolve that problem. And Django already does that in some parts of the logic. I mean, a lot of people use request.user quite often. And well, you might wonder, what if the view doesn't need request.user? Then there are a lot of queries to the user table that ask the logged in user, and that generates a lot of extra work for the database. But that's not the case. So what Django does is it works with lazy objects. And what's a lazy object? Well, a lazy object is a special class that has some sort of factory inside it. And that means that if you access an attribute of that object, or you invoke a method of that object, or you set an attribute, or you access a property or whatever, it will run the method wrapped inside it and use that, and then act as a proxy to that object. But as long as you don't need any attribute, you don't need to call any method or whatever, it will not load the function that wrapped inside it. So that means we can use this simple lazy object to postpone the database query until we really need something from that object. So for example, if we would replace our code of our user path converter with this simple lazy object instead of an eager query, we now can still define a view like profile. And for all we know, user is a user object. It is not, it is a simple lazy object, but it acts as a user from the moment you need something from that object. And so that means, in this case, if during business hours, our view will do a lot more work than outside business hours. Why? Because as long as we are outside business hours, we don't print the user ID, so there is no need to evaluate the user. And this thus prevents making queries that are useless in the view. And an extra bonus of this approach is we can subclass the simple lazy object and do some extra logic there, such that if we need the username, we don't have to do the query. And why do we don't have to do the query? Because it's already in the path. If you visit profile my username, and you ask what is the username of that user, we know it's my username. We don't have to do a query for that, right? An extra bonus is even we can omit the query when setting a foreign key. So imagine that you here have a view function where you want to link an article to a certain author. Well, then the path can look in the old way of doing it as an article ID, which is an integer, the author ID, which is also an integer, and we want to link those together, right? And so what you can do is you first fetch the article with that primary key, then you fetch the user, which is just the author, and then you set the author of that article to that author and you save the article. Now, if you develop a bit in Django, eventually you can see that there is a bit more optimized way to do that. And how does that work? You first fetch the article, then you don't need to fetch the author. You can simply set the author ID of that article and you save the article. And if we just work with our simple lazy object and we do some extra logic on top of that, what you can actually do is work with an article, which is a lazy object, with the author, which is a lazy object as well. And from the moment we set article.author, it will fetch the article from the database, but it will not fetch the author, so only the article. And so that means that we save one round trip to the database in this case. It, however, requires some technical details, and I'm not going into details about this because, well, it's quite complicated to explain in a 45-minute presentation, I guess. But, well, to summarize this approach, I think it's more transparent to actually work with model-based path converters. It can reduce the amount of code, I think, well, not significantly in the sense that it will halve the amount of code of a view, but still most views start with some database fetches. You can also make it if your field changes. So imagine that you have a model that's first an integer field for a primary key, and later on a UID, that it automatically converts the path converters. So you don't have to waste an entire day changing the patterns of your paths. And as discussed, it can reduce the number of database queries to the database. So what are the potential problems with this approach? Class-based views will need to be adapted to this. Why? They have a lot of logic like get object, get query set model, etc. So they are always focused on fetching one object from the pod, from the database into memory. That is, of course, also a bit a reason why a detail view is sometimes not very useful if there are multiple objects in the pod, for example, because it only focuses on one pod pattern. And another thing I think is sometimes problematic is that it's less predictable if and when those queries run. That is especially problematic if you update certain records in your view, and depending on whether the query is evaluated before or after the update, you retrieve a different object into memory. So, well, I will give a very short demo about this. So essentially can everybody read the code? No problems? Okay. What you here see is I defined two pods, one with an article ID and a username, and we want to link that article to the user with that username, okay? And the one below that is the handler to actually link those articles. So it takes then the ID of the article, the ID of the user, and we can link them together. So how does the link article template exactly works? Well, it doesn't do much. It simply renders a template, the sample form, with the article and the user. And in that sample form, what we do is we go to the link article with our article and user object directly, right? So without having to fetch IDs or whatever. If we load this in our browser, just give me a minute. Okay. Then you will see the form popping up. And so, well, perhaps zoom in a bit. So it has here generated the URL that it's going to use. I only did that for debugging purposes. And what you see on the console, if you want, is it's well, logged what object it's fetched from the database. And what you see, it's fetched the user from the database. Why? We have given it the username and we need the ID. So we definitely need to do a query, but it hasn't fetched the article from the database. So we here have saved one database query. And so what we can do is now actually trigger the logic with a post request. So let's link them. And if you take a look at the console log back again, it says, look, I fetched the article and it has not fetched the user. Okay? So, well, for debugging purposes, I introduced, of course, a print statement to actually know when a certain object is fetched into memory. And as you can see, the view actually treats it as if article and author are an article object and a user object. So there is a lot of, well, extra logic necessary for this, but eventually you can let it work so that the number of queries is reduced. Okay? That's, I guess, the demo for this part. Okay. And so that's essentially the first topic I wanted to discuss. The second one is automated overlap checks. And while that's a bit of a different topic, we will see that it has some overlap with the first topic, which is, of course, a bit ironic because we're talking about overlap. So, well, we already actually discussed it to some extent. Pods can overlap. For example, we here have defined two pods, one with a comment and a slug, and one with a comment/add. Now, if we're going to visit comment.add, what will happen is it will visit the first pod, right? And why is that? Because the text add is a valid slug as well. And there have been numerous hours wasted on this kind of problems. And why is that? Because a lot of people think, oh, look, it doesn't work. And they think it's the second view that actually is the problem. So they start introducing all sorts of print and debug statements, etc. And they then think it's the code cache or whatever. But eventually they find out they are barking up the wrong tree. And so, well, that takes sometimes a few hours to realize. It also introduces problems with, for example, redirect. Imagine that you do a redirect or a reverse or a URL. It will try to generate a pod based on the name of the view and the parameters you provide. But that it's not set that that pod will really route towards that view anymore if the pods overlap. And so, well, that made me think, as we discussed before, pods are actually compiled to regexes, right? So the pod converters we introduced earlier have regex in them. And what we actually wrote with the comment and slug was actually a short version of this repod thing where we introduce a regex, right? It's only that the regex is hidden in the pod converter and we don't have to deal with it. Now, regexes have been introduced by Stephen Kleen, and he also did a lot of research on them, and it turns out that if you have the intersection of two regexes, that's always a regex as well. And you actually can calculate the intersection of two regexes. And that's not in the standard regex library of Python, but there are packages like Greenery that can do that. So you can provide two regexes, for example. So the first one is a lowercase a and then any uppercase character. And the second one is any lowercase character and an uppercase character between A and M. And what it can calculate is the regex that only accepts strings accepted by the first two regexes. And, well, the Greenery package is not entirely perfect, but that has nothing to do with the regexes fundamentally. It's just that they introduced all sorts of special syntax on top of those regexes, like word groups, etc. And Greenery apparently has some trouble with answers, word ranges, etc. So, but you can massage basically a regex such that Greenery understands it. And so, why is that useful? Well, we can check if there is overlap between those two pods simply by looking if there is a regex that intersects with those two regexes, and if that's not empty, then we know there is at least one string that is accepted by both regexes, right? And so then we can automatically detect that there is a pod that, well, can trigger both pods, that there is, well, a pod in the request that can be triggered by both pod patterns, and that just means that there might be a certain problem. So how can we let this work? We first convert all the pods that we have registered to regexes. We check then the overlap for every two regexes, and then of course we report potential overlaps. And essentially we can detect three problems with overlap in order of more severe. So simple overlap is typically not that much of a problem. You can, for example, have here two pods where you want to, for example, like a certain post based on a slug, and a second pod where you want to list all the posts of a certain author by another slug. And, well, if you have a post with a slug author, then, of course, there is a certain intersection between the two. Both pods could accept the pod at the bottom, and in this case, it's always the first one that will accept it. That's not per se a problem. As long as there is no author with a slug like, that's fine. But that means that you would have to think, oh, the author should not be like, right? A more severe one is that the second pod is contained by the first one. For example, here you have two pods, where the first is a help and then any pod, and the second is a pod that starts with help, about, and then any slug. And you might think, oh, if I go to help about foo, I go to the about page, but that's not the case. And regardless what pod you hit, what request you are making, the second view will never get triggered. Why? All the pods are captured by the first pod pattern. And so the only way to resolve that is to swap the two pods, so that the second one at least has some chance to capture certain content. And finally, we are actually back to an example in the previous topic, that is, that if the two pods are equivalent. In that case, swapping the two is not a solution because they are equivalent. So you actually, even if you would swap them, you would end up with the same situation. So that's quite problematic. And in that case, I would advise to find a way to make them non-overlapping. So how do companies sometimes do that? Well, for example, IMDb uses a prefix for this. So if you have a title on IMDb, it prefixes it with TT, whereas if you have a name, so for example, an actor, it has an M as a prefix. And that means that even if later on you have a URL where both the title and a name can be put in, at least you know that if it's a title or a name, right? So what would be the pros of such a tool? Well, it can prevent mistakes, and you can also add it into the CI/CD pipeline. The potential problems with this is that you first need to fix the regex such that Greenery understands it. And well, it's not entirely clear what Greenery accepts and doesn't accept, so that will require a lot of work to rewrite the regexes. And sometimes overlap is acceptable, of course. So as we discussed with our author that should not be named like, for example, sometimes you say, okay, that's one of the conditions of an author, that he should not be named like. And then you can implement that simply in the view logic. So I can give a short demo about that. So, well, I implemented this in a function, well, in a management command named URL overlap. And so essentially what it does is it looks for URL patterns that are defined. I defined some extra URL patterns here at the bottom to, of course, trigger overlap. And if I then run the management command, what it will do is it will look for all regexes and try to find overlap between all those patterns. So what does it list, for example? Well, it lists that we here have a path that's our article linking at the top. And at the bottom, I have a wildcard. And it says, of course, look, that's all very fine. But if you would have an article 1 and a user B, for example, the path will be /1/b/link. But that is also acceptable by a wildcard, where the wildcard is then 1/b/link. Okay, so there is an overlap on that. That's not really an issue here. But if we move further down the list, you see that it has found all sorts of extra overlap. And eventually it has also found overlaps that are more problematic. So just give me a minute to scroll. Yeah, okay. So what I did here at the bottom was I made a path pattern, which is a wildcard. So essentially it accepts everything. And then I define the path unreachable. And so regardless how you try to trigger the unreachable path, it will never happen. And it has detected, okay, the pattern with the wildcard and unreachable overlap, for example, with that /unreachable. But since all captures of the second path pattern are also captured by the first pattern, the second pattern will never fire. And so at the end, it lists hints how you should reorder the paths such that all your paths eventually got triggered. Now, I use this tool where I work on my workplace, and we found a few of those overlaps. Typically, that's not because you have an off day as a programmer and you don't see it, but what essentially happens is someone defines a path, and then someone else comes and he defines another path earlier in the sequence, and well, eventually certain views might not be accessible anymore. Okay. So that was the demo of the second topic. And well, I'm implementing this logic in a GitHub repository. Well, initially I had the idea that that would be finished by now, but I found some extra topics and IDs. So, well, it's still under construction, but I hope to finish it by the end of the year. And so that essentially concludes the talk. Okay.
Earlier, you had mentioned class-based views as opposed to the implementation that you had here. Can you go into more detail on how to implement this for class-based views?
Well, actually, the way how you could do that is simply removing the get object. So the object is already in the URL path, so in the quarks, so to speak. And so that means that the get object becomes quite useless. So it should no longer take the ID parameter or whatever. It should essentially do nothing, so return none. Now, that will not really work because a lot of the extra detail view logic depends on that. So essentially what I think is the best way to handle it is that you, in a detail view, give a name of the detail object that's already in the quarks, and then you treat that as the object. And so that will also work by most of all the extra mixins that are built on top of a detail view, for example, because if you would have a mixin that says, oh, you have the get object, and I want to, for example, load related objects into memory or whatever. You want the get object to really give you the object and not just none, right? So I guess that would be the simplest way to fix it. But well, it might still raise some extra issues.
And thank you.